Welcome everybody. My name is Vince Arnesia. I'm the Chief Product Officer for Five9. Joining me today is Rob Conley, as usual, our Senior Systems Engineer who works a lot with customers and drives a lot of our demonstrations. Today's agenda is to cover cloud security, which I know is a general term, but we'll give you specifics around what that means for Five9 and how it really refers to your virtualized infrastructure, both for on-prem and cloud. We are, with this particular webinar, changing from Five9 Demo Friday to Five9 Demo Series. A lot of that was driven by feedback from you specifically as it relates to the inability to attend on Fridays, especially for folks overseas. And so doing it midweek seemed to make more sense. And so we'll be doing these on the same 2-week intervals, just every other Wednesday going forward. Also, these webinars are in fact recorded and put on the Five9 website, and they are of course also emailed out to everybody that registered. We'll go ahead and get started. A couple slides just to get everything set up. Five9, a little bit about the company. So for some of you that are new to Five9, we've been around since 2012 from an official product perspective. Over the years, we've accrued a lot of customers, global customer footprint, really spanning a lot of different verticals. Obviously, as you can imagine, the software is very much vertical agnostic. We do very much focus on your infrastructure and helping you manage and secure your infrastructure. Today's topic is around securing your infrastructure. The next webinar will be focused around managing your infrastructure with the new release, which will be version 4.0. So we'll go through that on April 10th. Because of our focus towards the Microsoft cloud, we obviously have a deep relationship with Microsoft. We work with a lot of different types of companies, SMB, mid-market, large brand names that most everybody would recognize, and then also service providers that leverage our platform to serve their customers, both as a sell to and a sell through. And then of course, the mission is to make the life of a system administrator really easy, to help them simplify, optimize, and secure their Microsoft cloud. So the trend that we're seeing is best captured here. We're seeing a lot of our legacy customers go to what's referred to as infrastructure up. They're effectively extending their on-prem environment and incorporating public cloud in some capacity, whether it be for replication or backup or moving of workloads, etc. And so what that really entails is it also carries over to security. When you extend and you go to infrastructure up, you have to account for security. And maybe you've been doing that pretty well on the on-prem environment, but now you're looking for solutions to help you secure your virtualized stack on the public cloud. And of course, we'll be addressing that here today. The Five9 platform is extremely comprehensive. If you look at all the different products we have, these are the different features and functionality that we do cover. You can see here our focus is on the bottom right today with security and the various features within there. But Cloud Manager gives you management, replication, monitoring, optimization, backup, and extremely granular administration, role-based access control. And then we also have a cloud migration product, which allows for you to seamlessly move from one environment to the other. And so, of course, we cover HyperV, Azure, and we are actively working with Microsoft on Azure Stack support, which Microsoft is heavily investing in, as you probably saw with some announcements over the last few days for Azure Stack hyperconverged infrastructure. As far as the feature set within cloud security, so when we refer to cloud security, those, as I mentioned earlier, are very generic terms. What we're really referring to is the ability for you to protect your virtualization layer, your host, your VMs, everything that you sort of utilize on your day-to-day operations for your infrastructure. And in some cases, we're seeing this with customers that are very security conscious, that are looking for security at all layers. In some cases, we're seeing customers that are dissatisfied with just having security at the perimeter. In some cases, we're seeing this with customers that are looking for ways to satisfy certain compliance or requirements that are being dictated to them. And so a lot of different drivers are leading to customers assessing solutions that are focused on protecting their infrastructure, their virtualization stack. The feature sets we offer are focused around providing a virtual firewall, of course, around agentless antivirus, which Rob will go into in some detail, intrusion detection, which we're actually using Cisco Snort for business, deep packet inspection, anomaly detection. So the kinds of features you would expect from a network security solution just focused around the sort of the virtualization layer really lends itself for you to be able to use a multi-layered offering and really cover both internal and external threats. And we see that quite a bit with customers looking for ways to protect against the insider attack as well. And then, of course, when you look at this circle of features, you end up reducing a lot of costs because you're able to accommodate all of these different multi-layered threats with solutions via one product, which is the Five9 cloud security product. When you think about Azure, you might be thinking about solutions that are very focused on Microsoft Azure via the Azure Security Center. And that would be sort of normal. When you start to dig underneath the covers here a little bit, you'll get a sense of the Azure cloud security really being a what I would call a best practice analyzer. It's really more focused around reporting security misconfigurations and still relying on third-party partner solutions for actual protection. And that's really where a solution like Five9 comes in. It's actually giving you actual protection, preventative, detective. I showed the features earlier. Those are kinds of features that are typically not offered within Azure Security Center. And if they are offered, like the notion of a virtual firewall, it's not with the level of flexibility or configurability or depth that a Five9 solution provides. Same goes for the OMS security. Really, the way to look at that is it's really a collection of solutions that are out there. Once again, more focused on analytics, high-level analyzing of offerings. So not really one that compares, at least in our mind and our customer's mind, with the Five9 solution, which gives you, sort of a comprehensive solution set. As far as the NIST requirement, this is something relatively new, especially revision 2. We've seen traction from customers that are in the government space that are being told, based on this new revision that came out a couple of months ago, to enhance their controls for what's called CUI, so controlled unclassified information. And so a lot of these federal agencies are working with government contractors or folks that are just helping with the supply chain, and the need for protection for CUI is explicitly listed out in 3.13 within that particular NIST requirement as systems and communications protection. And so Five9's offering is not only able to easily satisfy that, but it's also very cost effective. And we've seen a lot of the smaller government institutions, government agencies and government shops that are working with the agencies look to somebody like Five9 to help satisfy that, and yet at the same time, be able to meet their budgetary constraints and other limitations that they might have to live with. So with that, I'm going to pass it on to Rob. Rob is going to now give you a demo of these features, and then we'll open it up for questions at the end. So feel free to ask questions, and we'll address those towards the end of the webinar. So thanks. Over to you, Rob.
Thanks, Vince. Hello, everyone, and thanks for joining today. First off, we're going to go ahead and share my screen here. Hopefully, everyone will be able to see it in a second. There we go. So what we're looking at here is the Fine Cloud Security web interface. And so the cloud security has a few different consoles or ways to access available. And so this is the web console, and it is a fully multi-tenant solution where you would log in, and then once you log in, obviously you're able to review your antivirus settings, your intrusion detection. You can make any adjustments to the virtual firewall. You can see the different traffic flowing in and out. You can take a look at your different machines and maybe drill in. So what we're going to do today on the call is just going to kind of go over some of these features here that are available and exactly how to implement them and kind of the best practices around adding these types of security layers to your Hyper environment. What I'm going to show you now is exactly how we do that. Go ahead and jump around screens a little bit here, everyone, so if you can bear with me. So what you're looking at here is exactly how we do it. What we have is we have a management server. So the management server is a virtual machine, or it could be the hardware that you deploy. Running on that management server is the cloud security management service. And that management service speaks to any of the consoles. So we just looked at the web interface. The other thing we have is the 5.9 management console. We have a plugin for SCVMM, and we even an Azure Pack Portal plugin. So those consoles speak over this simple port to the management server. The management server is speaking back and forth to all your different HyperV hosts. And those HyperV hosts are sending back AV definitions, for example, IDS, and also collecting the updates out on the internet for your antivirus definitions. So the whole orchestration of all your different IDS and AV updates are all handled by the management server. The management server will receive them, deploy them throughout your environment. The next thing I'll do is just kind of take you through the 5.9 management console and kind of show you how we work with that. 1 second. All right. What you're looking at here right now is a virtual lab that is actually available to everybody. It's on our website in the resources section, and you can view both cloud security and our cloud manager product. And in the virtual lab, we've provided some steps, but I'm going to use the lab for part of the demonstration today. And if you want, you can even go to the website and start your own lab in the background. So what you're looking at here is the Cloud Security Console. So it's just a different interface exposing the security platform, similar to the web interface. So we'll kind of go through what we're looking at here. This is a HyperV host. This is a HyperV host. These are the virtual machines running under those HyperV hosts. We can secure all of this infrastructure here, whether it's a host or a virtual machine, with a virtual firewall, antivirus, intrusion detection, network anomalies, network traffic scanning, and some other details here about the hosts. What you'll see here is that I can enable the virtual firewall as I right-click on these machines, or I can actually scan them with a default AV scan. Obviously, most people on the call today probably have a firewall, have some sort of antivirus, maybe do have an IDS, some sort of network detection software. But what really makes us different, and in terms of where compliance, especially the NIST compliance, is we're bringing the security layer. We're bringing the security layer down to the hypervisor itself. So that's really where all this is a little different with 5.9 solution. Starting at the virtual firewall, for example. So the virtual firewall is applied on the virtual machine. So this virtual machine has the virtual firewall running on it right now. If I click load log, I can see the traffic flowing in and out. It's blocking a lot of traffic. I started a ping earlier. It's blocking my ping. And um, all this traffic here is being blocked actually at the hypervisor layer. So when that packet's coming in, for example, the internet, it's coming into the hypervisor itself, and then that hypervisor is passing those packets down to the virtual machine. So I'm blocking these packets right now on this virtual machine from the hypervisor layer itself. The way we do that is we actually have our own technology. What we're doing is we're actually injecting a kernel mode driver into the hypervisor's virtual switch. And once we're running at that lower layer of the operating system, we can then inspect packets flowing in and out of the virtual machines, between the virtual machines, and between the hosts and the outside world. So since we're able to inspect those packets, now we can make decisions on them. Do we allow it? Do we block it? Does it contain some sort of malicious packet? Is it some sort of network anomaly or an IDS? So what kind of makes this different is in the scenario that most people have today, you might have all your security up on the border. So on your border, you have your firewalls, and you have potentially an IDS device or other type of security appliances. But what we're seeing is that if somebody does break through that border and lands on this underlying virtual machine, VM web server, for example, they're on this web server, they then can attack potentially this virtual machine or the host without those packets ever traversing all the way back up to your border. And so what this does, it allows them to live inside of your network or some sort of infection or malware to live inside your environment, potentially without your border ever knowing about it. So that's why it's important to actually have another security layer down at the actual hypervisor layer. So in this case, the hacker, we'll call him, has landed on the VM web server. And so typically what they would do, the next thing they would do is they would disable any antivirus that's running on that virtual machine. They'll disable any local firewall running on that machine. And then they'll go ahead and attack the other machines in the environment. So what makes our solution different is when that hacker lands on this VM web server, they are not able to disable any security services because they're running at the hypervisor layer. So I can click load log and watch all the packets that they're sending in and out. I can right click, I can add a rule to potentially allow or block those packets. Or I can come up here and add a rule. And it gives that layer of security above. And in addition to that, I can also limit the scope that this virtual machine is able to speak to on the other virtual machines in this environment. So that's one of the things I wanted to point out with the virtual firewall today that might help you. It's a way of limiting what this virtual machine can actually contact. Similar to like a microsegmentation approach. The way that I would do that is first off, we have to allow some traffic through. So right now I'm blocking ping. So the first thing I'm gonna do is add a simple rule to allow my pings. Allow ping. So obviously you can select your rule direction, the action type. So I want to allow this. Protocol is going to be ICMP, and we'll select all the different ICMP types. Push OK. What this has done now, it's went out and sent this rule update to this HyperV host, but it also sent the rule update to this HyperV host. And as those rule updates are flowing down, they're actually sent to every single HyperV host. So this rule exists. The reason why that's important is if you move this virtual machine to node 1, you need to make sure the security moves with it. So every HyperV host has a set of all the firewall rules. So now I'm allowing ping through that machine. So what if I wanted to allow this machine to also speak to my SQL servers and maybe also speak to my IaaS servers? So what you might do is you just will allow that network traffic, but the VM web server itself doesn't need to speak to every port on the IaaS right here, this machine. And if someone did ever attack VM web server, I want to make sure that they can only contact the ports that are actually required on VMIS. There's no reason to give this machine full access. So to do that is up here in the global rules. So in global rules, I'm going to add a group here. This is a very simple example. We'll add web servers. And then up here in the global rules, I'm going to add another example. We'll call this SQL servers. So this is a way of organizing your equipment and providing the rules needed for it. So in this case, I'm selecting SQL Server. I'm going to add which virtual machines, existing or new ones that have been added, are my SQL servers. So in this case, it's just this one, but there might be others in most environments. And now I'm saying every member is also going to receive this firewall rule. So I'm going to add an IP rule, say allow SQL, and it would be TP 1433. So you notice now if I select my VM SQL, that rule will be applied. That VM is part of this group. So also create another web servers here, same idea on web servers. I'm going to virtual machines. I'm going to add the IIS server now. I'll add both my IIS servers. And in my servers, I obviously need to add a rule. I'll just do it through a temp to make it easy. I'm going to add HTTP. So now all my web servers have a rule that allows port 80 on it. So I would go through and add all my different application types here and add the virtual machines that are associated to those ports. If an SQL server is also running HTTP, it can be a member of this group also. So the same machine can be part of multiple groups. But the reason why this is important is coming down here to this web server. So now I want to give this web server access to this different pieces of the environment. Because right now it has no access other than my ping that's allowed right now. So I'm going to go ahead and say add IP rule. I'm going to say allow SQL. And I'm going to go down here and say remote VMs. And I'm going to select SQL servers. So now this virtual machine is allowed to speak to any virtual machine that is a member of SQL servers, but it's only going to be able to speak to SQL servers, obviously over the port that's specified, 1433. The next thing I want to do is I want to add another rule. I also want this to speak to my IIS servers. Same idea. I'll just come down here, select web servers, and now it's going to be able to see the web servers. So what's happening here is now if someone did land on VM web server and they did want to go and attack the other infrastructure that resides in my environment, they're only going to be able to attack, for example, this IIS server, and they'll only be able to attack that IIS server over 80. So that's the idea of the microsegmentation, or at least our approach of it, as a way of limiting the scope of what each VM could actually speak to, and also being able to monitor that traffic that it's speaking to. So that's the virtual firewall. Another thing that's really unique about the virtual firewall itself too is that the virtual firewall relies on MID. So you can actually change the IP address of your virtual machines. So your IPs might be able to change daily, but the security rules would still apply, because the security rules that we apply to virtual machines are based on VMID, not on IP. Typically, a border firewall relies on IP based. So we're a little different in that aspect too. So you can change your IPs. You don't have to be coming in here and adjusting all your firewall rules. All this traffic you see down here is actually being sent out also to our internal logs, but you can send this out to syslogs. This goes back again to compliance. There's a lot of compliance out there that requires you to store the traffic data of either your hosts or your virtual machine. The software allows you to take all this traffic data, push it out to your syslog server, something like a Splunk, and you can record this data for your compliance. All right, so moving along, next would be the antivirus. So in antivirus, we We have two types of antivirus. We have agentless antivirus, and then we have active protection. So the first one, agentless antivirus, is the method where we scan the virtual machines without any agents actually residing on the virtual machine. So back to our hacker, he lands on VM web server and puts a virus on that web server. We're going to be able to detect that virus without even having an agent that resides or runs within that operating system. So that's another piece of our technology. And we also have another thing that's a change block tracking driver. So you'll notice here, I scan this virtual machine and I can create a job either by right clicking, just saying AV scan, come up here and actually create a job where I can scan either my VMs or my hosts. And so what happened here, this is my first scan. The first you scan any of your virtual machines is going to be the longest scan possible, because we need to scan the first block and we scan all the way to the last block. Once we complete that scan, the second pass, we're only going to scan the blocks that have actually changed on that virtual machine. So you can see that technology in action here. The first scan of this web server was actually a web server, took about 5 minutes. The second scan only took 16 seconds. Reason being is because it only scanned the blocks that have actually changed. So it's a little different mentality than what administrators are typically used to. With 5.9, the more you scan, the quicker scans become. Also, by using change block tracking, you're also reducing the IOPS on your system. And best of all, in this technology, using the agentless approach with your security, you're not having to deal with agents on every single virtual machine. So that's another problem that I kind of wanted to point out too, is that a lot of people on the call today, if you have some sort of AV out there, it might be agent-based, or most likely is agent-based. And so what this means is you have agents running on all your virtual machines. And in some cases, some of our clients have thousands of virtual machines. So that in itself can become a big process to manage and maintain all those agents speaking back to the central repository. In this case, very simple, no agents to deploy. You just create a scheduled scans. I can create a job that scans these VMs every hour, or I can create a scan job that scans every night. And we'll do the agentless. And here's the quarantine. So on my first scan here, I found some viruses. It notified me of the virus, and I can go ahead and take action on that now. So we have another method of antivirus. It's kind of a step above scheduled agentless scans, and that's active protection. So what active protection is active protection I would use on your virtual machines that you're doing like a VDI type scenario. Basically what I mean by that, it's a machine that you have a user on it, they're downloading stuff off the internet, they're working, and that user has the ability to potentially very quickly lock that machine, download viruses, or maybe it's a user in the past that has had a problem with download viruses. What I would do is I would inject this active protection. So what it does, it actually does inject an agent on that virtual machine, and it's kind of an extra layer of antivirus. Again, you would only really typically install active protection on those virtual machines where there's really a high level of infection on that virtual machine. Typically, in most cases, you can cover with agentless scanning. So now that we've found some viruses on this virtual machine, I want to remove these machines from the quarantine. How we do that is also a little different. You'll notice here that it's going to say Reboot Action, telling me that it wants to reboot this machine to delete these viruses. What I would do is I would click Reboot Now, and we would actually reboot the virtual machine, and while it's down, we remove the threats, the actual bad blocks, and then we turn the virtual machine back on. So I have one ability that most antivirus does not, is because we're not running at the OS layer, we don't worry about things residing in memory, the service somehow not being able to disinfect that virus unless you boot into safe mode, stuff like that. That's not a problem. All we do is we just shut the virtual machine down, attach to the virtual disk, remove the viruses, turn it back on. So that's the process of antivirus itself. Again, all this data comes out to syslog channel. It can be stored for your compliance. We also have some other tools up here in the view. You can see the antivirus status of your environment. You can also see the user action logs, which is basically a log of every single event that any user has taken inside this software. Internal events audit is a report of any event that's happened inside the environment, and obviously any antivirus events. So all these also, in some cases, are required for compliance, so they're available for you here too. So next is intrusion detection. So what this does is going to scan the virtual machines. On this virtual machine, I don't have any intrusion detections. I can actually create some, but let me do that right now real quick, and I'll show you exactly what the ID is. In order to do that, I'm just going to allow all traffic. This just takes a second here. I have this little tool here that's available on our virtual lab, and all I need to do is put the address of that machine. And what it does, it sends some bad packets to a machine, so you can inspect how the software reacts. So if I set everything up correctly, I should see that attack in here now. Yes, I do. All right, so there's the attack that I just sent across. These bad packets, they're prioritized 3 to 1 based on the scale of the attack. And you could filter these results. But so what happens? The hacker lands on VM web server. He then either is spamming or sending out stuff out to the internet. Maybe he's attacking these other virtual machines. We see both. So you'll see that if this virtual machine was attacking IIS core, it would show the source VM, destination, or the 2 VMs here. Otherwise, if it's external to the environment, it will show the external IP addresses. So I can right click. I don't like traffic here. It looks really bad. I'm going to add a rule to block that traffic. So this information you'll also is stored within the logs, sent out syslog, and all these events are also sent to you by email. So you can configure email alerts too. But the object being is that you would receive some IDS events if this machine is compromised. You can come in here, review those IDS events, and potentially block that traffic. All IDS events are updated from Cisco Snort for business. Same with the virtual firewall. In this example, I'm using Bitdefender. So all these updates are obviously included with the software. It's not to go out and buy Bitdefender or buy Cisco Snort. It's all included with the software. The software, as I said, handles all the updates to all the different HyperV hosts. So network traffic scanner. I can show you a network traffic scanner on a different environment, but I guess I'll just speak to it for now. Basically what it's doing here, the network traffic scanner is scanning for viruses at the network layer. And this is over port 80. So basically what happens is I'll refer to that user again that's out on the internet and they download a virus. Let's say they're on VM web server and they download a virus. What's going to happen is the moment that virus hits node 2, it's going to trigger network traffic scanner because we're living in the HyperV. And we're going to send out an email, create an alert that VM web server is downloading a virus. That virus then lands on VM web server. Antivirus, if enabled on that virtual machine, will then clean up the virus. Network traffic scanner also scans between virtual machines. So that's also important too. So if this virtual machine is infected and he's trying to send viruses to these machines or this host, we will also pick that up. We can look at the connections running in and out of the virtual machines. This is really simple. This virtual machine only has me connected to it right now. So, but in most cases, you would see a lot of different connections, and you can actually sort those connections by type. And then statistics are going to give you some basic statistics about this virtual machine: packet size, packet speed, and these reports can obviously be configured and compared, obviously, with previous dates. These reports are great for a quick view of your traffic data. It's going to give you the details that want to see in terms of packet size, traffic, and packets. But if you're really looking to get really detailed analytics about your traffic, whether it's security related or just general traffic data, I would again suggest to use the syslog method, use something like a Splunk other tool, and then you could really crunch that data down exactly how you want to see it. So up here in the settings and the view tab, I just wanted to point out a couple other things real quick here. This is where we set up our email notifications, network anomalies. And we kind of passed by that one. Network anomalies. So what network anomalies does? Network anomalies I don't have right now, but I noticed I skipped past it, so I'm kind of backing up a little bit here. But the network anomalies are going to detect how this virtual machine utilizes the LAN. So it goes back to that attack. I'll just use that state again, where someone lands on this virtual machine. Every day, this VM web server using, let's say, 5 megs a second on Wednesday at 10:53 p.m. That's its average. So our software is using machine learning to determine how this virtual machine is utilizing the LAN on a daily, hourly basis. And so what we look is for deviations. Yeah. So a great example would be if someone did land on VM web server, the way this web server utilizes the LAN or the WAN or any network connection is going to change. They're going to go attack this machine, maybe this machine, the packet size might change, the speed is going to change, and we're trying to detect those changes. And we will alert you if there is what we refer to as a network anomaly. We use machine learning. We first install our software. It takes a little bit of time in order for this to create a good baseline, but once it creates a baseline, it's continually adjusting that baseline as our software is enabled. So what I showed you here is actually security on premise. So in this case, we have HyperV hosts, virtual machines, but let's say you have SDN deployed. So if you have SDN deployed, we do have a solution for that, and it's the same cloud security, but it works slightly different. You have SDN. What we do is we deploy a virtual route into this scenario, and all the packets are flowing through the virtual router down to the virtual machines and HyperV hosts. We do fully support SDN deployments. The other thing we support is Azure. So now Azure Security is available. So all the features that I showed you here today are also going to be available in Azure. What I'm going to do is flip over to the Azure console and just kind of give you a quick view of how the Azure console is. So what we're looking at here is the cloud security for Azure. So this is actually running right now a virtual machine that I deployed in Azure. It's actually running on that one right there. And what I've done is I've deployed a piece of software called the 5.9 router. And what this router is in Azure, it works just like the SDN that I expressed, where it's going to route the traffic for your Azure virtual machines. It's going to route that traffic through the Azure router. The reason why it does that, it's kind of obvious because in Azure, we don't have HyperV hosts any longer. We only have virtual machines. So Azure's not going to let us inject our kernel mode driver, obviously, into their, into the Azure HyperV hosts. So what we do is we use this Azure router, and it's a great way to do the exact same inspection that we're doing on the HyperV host level in Azure. It's very simple. You deploy this a router, the traffic flows through it, and as you can see, I can load log, look at all the traffic flowing through my Azure virtual machines, and just like before, I can add rules to block that traffic. I can micro set my traffic here. For example, I can create different customers and say this VM can talk to that VM. Much easier to use, obviously, than the firewall built into Azure. And it does add these additional features on top of that. You also are getting the antivirus, the same antivirus we spoke about before, next to the virtual machine, scans the blocks, has the change block tracking. So it's exactly the same solution. The only difference is we're using this router because we don't have the HyperV hosts. Up here is your Azure subscriptions. So you add your different Azure subscriptions. So if you're a reseller, you might have multiple subscriptions. You can manage multiple clients from the single interface and have like a global view for all your security. And of course, this also supports the ability to take all this Azure data, send it out via syslog, Microsoft LMS, maybe Splunk, something like that. And I'll allow you, again, for compliance reasons, to keep this traffic data. So I was able to give everybody an overview on the cloud security, maybe provide you a little bit with some details on how you can secure your environment. I guess to go back to some questions and stuff, I'm going to go ahead and pass it back to Vince here, and we'll see what we got.
Okay, great. Thanks, Rob. So a couple questions that I guess we'll get to now. Does this apply for Windows and Linux VMs?
Yeah, great question. I didn't cover that. So it actually will support any virtual machine that is running on the hypervisor itself. That's because we don't install any software, obviously, on the virtual machine. So it can be running any type of operating system.
Okay, great. As far as antivirus, can you spend a minute on going through the different engines that we support? Because there's a question here about Bitdefender, but we obviously support primarily Bitdefender, but more than that.
Yes, so we support Bitdefender, ThreatTrack, and Bursky. So it's up to you to pick your antivirus vendor. In most cases, we're doing Bitdefender. That's what I demonstrated to you today. But how the software works does not change. We just give clients, depending on where you are, maybe you have a preference of an AV vendor. You can just select which sector base we're actually using.
Okay. Next question is Azure and HyperV part of the same product? So I'll take that one. So no, the Azure part of cloud security by Five9 is actually a separate product. It's offered as a separate licensing product, just like the HyperV product is offered as a separate product. If you're using and starting to run in a true hybrid environment, you would need both products in order to protect your comprehensive infrastructure. There are plans in the future to merge them under a unified management console, but the licensing of that would still be separate. But at this point, they're two separate products and allow for you to configure those separately. The last question I see here is around the log data. Can this be used with any SIM system? Maybe you want to address that, Rob?
Sure, yeah. So most systems support syslog. It's widely used method, and it's probably one of the oldest too. So as long as the system supports syslog, and most do, then it's easily covered. And basically what you do is you enable it here, and you would just put the IP address of your syslog server. If you're using some type of RFC header, potentially maybe authentication, you would enable this.
Okay, great. Thanks for showing that. Another question, does AV run multiple engines concurrently?
No, you would select one of the three current providers that we support. We actually suggest a best practice to not have multiple AV on a virtual machine. It's just going to add additional IOPS. So we suggest then deploy just one AV engine, depending on which one you select.
Yeah, and I'll just add to that, if you are in a position to select the AV engine, our recommendation would be Bitdefender, just because of what we've seen as it relates to them keeping up with the latest threats and signatures, and just the overall solution from a performance perspective. That's typically the one that we favor and default to with any customer.
Yeah, that's correct. The Bitdefender is currently the most popular solution, and it's one of the reasons why I deployed it in all of our example environments. It's the one that, if anybody asks me which one do I suggest, that's typically the one that I would suggest.
Okay, great. I think that's it for questions. I do want to point out one more thing. You just saw the feature set for cloud security. Obviously, as any software vendor does, we are evolving the product on an ongoing basis. So in the next release of cloud security, which will be made available in the next 2 to 3 weeks, we will actually be adding another feature for anti-ransomware. And so what that really means is we will allow, through the same interface that Rob is showing, the ability to configure protected locations and trusted processes where you as a sysadmin can basically dictate where you want these restrictive access controls to be placed so that those locations, those processes can be prevented to being susceptible to ransomware because that content will effectively be encrypted. So that feature with that UI configuration will be released, I would say, in mid-April or so. We will, of course, demonstrate that to our customer base, our prospects, in one of these demo series in April. But as you are looking for additional security controls, just be aware that that ransomware detection, ransomware prevention, sort of proactive prevention capability is forthcoming. Rob, anything to add to that from your customer experience as it relates to that upcoming feature?
Sorry, I was on mute there for a second. Yeah, so the ransomware is something that obviously I hear on a majority of my calls. The Cryptolocker is obviously the most popular one these days. And so, as Vince explained, yeah, this is really going to help a large group of administrators that deal with the ability where they want to give a share out. So this is typically what I see in my environment. They have users that have shares attached to their virtual machines. Those shares, for example, can become crypto lockered. Other things that can also be crypto lockered might be a path on your environment, let's say C Windows. So what this is going to do, it's going to actually prevent those paths from being crypto lockered or protected basically from adjustments. And this is something that has been requested from us for a while. And as Vince said, we're very excited to have this coming very shortly. And I'm excited to show everybody on the call today.
Okay, we do have some additional questions that came in, Rob, so let's just address those because we do have a little bit of time. Does 5.9 support XenServer hypervisors?
No, not at this time. We only support HyperV and Azure.
Okay, and does the console support role-based access?
Yes, so it is a multi-tenant solution. So what you can do is you can actually very easily, I'll show you here real quick how that works. Let me just take a second here.
Yeah, take your time.
My lab timed out. So I have one more environment here. There we go. So in this environment here, we'll show you how it works. So here we have tenants. So what you're able to do is you're actually able to add a tenant and you give tenant permissions. So I can specify which virtual machines this tenant has access to, and then I can specify what features they have access to. So I can create a tenant that would then, for example, either log into the web portal or maybe open this console. And when they log in, they're only going to see the virtual machines that they have access to. And then depending on what you select here is which security layer they're able to make adjustments on that virtual machine. So yeah, fully multi-tenant. You create your tenants here. The tenants can access this console, or they can log in via the web interface, and obviously make any adjustments.
Okay, great. So I think with that, we will, hold on, sorry. There's another question. Can it be read-only from a permissions perspective?
That's a good question. I'm not sure about that, actually. I would have to get to you on that. I'm not sure.
Okay, we'll follow up with the person asking the questions. All right, well, thank you for your time, and thanks, Rob, for walking through the product in detail. As I mentioned earlier, we will be doing another webinar as part of our series on April 10th, where we will go over Cloud Manager with all of its new features in version 4.0. This includes features around tenant portal support, auto discovery of data stores, sort of a new look and feel for the interface, and a variety of new capabilities. So we'll be walking through that in a couple of weeks. Until then, please reach out to us if you have any follow-up questions, and thanks again for joining. Take care.
Thanks.